Hello my future engineers, how are you all? So welcome back to the channel, and today I'm completing the chapter integrals. Okay, the last topic which was left is definite integral, so we'll complete this in today's session itself. I have taken all the subtopics, whether it is substitution method, application, it is very important, and again the properties, we'll discuss all of them. And not only that, we'll also solve problems on each of the subtopics. That clear? Okay, let's quickly look at the session outline to understand what's going to happen in the today's session. So first one will be, as I said, of course, starting with the application of limits. How do we put limits? What are the limits applications or use in the integrals? Okay, so basically the definite integrals, we're going to learn about this. Then we'll move on to what? Then we will move on to your application of substitution method. And third, we'll have to learn today about properties of definite integrals. And lastly, I have taken total of 18 questions. That we're going to solve and also give you some as homeworks. Let's start. I know your time is very important, so it's very important to start as quickly as possible. So first one is, now looking at the subtopic, of course this is part of integrals, it's not a separate chapter itself, okay? It's a part of integrals. Now question, there can be two questions in your mind. Question number one, is it difficult? Second one, is it different? Is it different? Of course it is different, right? There's a difference between the definite integral and indefinite integral. What's the main difference? These are unique in nature. The main difference is, in the indefinite integral there is no unique answer because of the constant plus c. Every time you change the value of c for different boundary conditions, what will happen? The value of the integration will keep changing. Whereas in the case of definite, this is completely opposite. It is always a constant under a specific given limits to you. Now, so different, we have justified, yes, it is different from the indefinite category of integrals. Second question, is it difficult? Actually, no. Because if you have learnt a fair share of indefinite integral properly, the questions here are actually simpler than what you have learnt in the indefinite. Yes, there will be application of this over by parts, then those questions become difficult, but they are very few. But you have learned by parts there, right? So of course, so if you have learned indefinite properly, this is actually simpler than what you have learned in indefinite. Again, one more thing which is important over here is going to be calculations. Actually, in the case of indefinite, you have less calculations. You have more, use of algebra and formulas and those things. But here you'll have numbers involved. You'll have calculations involved. Don't worry, I'll give you questions like that. You can practice right away. Okay, and of course, now we can start with the chapter itself, the definite integrals. Have a look. So same thing goes. You're gonna write a function under the integration f of x and dx. If you write this, what is the answer going to be? Some function plus a constant. But if you are talking with respect to the definite integral, you'll have actually a limit a to b. Whereas a is called as what? A is called as lower limit, and the b is called as upper limit. B is called as upper limit. B is upper limit and a is lower limit. Got it? And the result, let's say I'm getting this result after the integration, I'm getting this as a function gx. Means if I integrate the function fx with respect to the variable x, I get the answer as gx. Okay, then you're gonna write this under the limits same way as a to b, and the result is actually given by the function g at the point b, which is nothing but gb, minus the function g at the point a. So this is the notation of your definite integral, and that's how it proceeds. Okay, means you're gonna integrate first, put the limits, and then simply substitute in the x as upper first minus lower. What is this? Upper limit value minus lower limit value. This will never change. Upper limit minus lower limit will never change. Okay, now one thing is very important to remember over here. Okay, that questions can come, and mostly the questions are coming in this topic will be from substitution method or application of by parts or properties. Three topics: substitution method, by parts, and properties based question can come from this particular topic of definite integral, and it has good amount of weightage. Okay, so we'll see that later, but right now we have some basic questions to solve on the definite kind. Let's see. So basically I believe in learning concept with the help of application. So let's learn the concepts application in the problem itself. First question in front of you, 3x cube minus 4x square plus 1 divided by root of x. Limits is defined from 0 to 1. Okay, 0 to 1 is 0 is the lower limit, 1 is the upper limit. Okay, so what is going to be happen over here? So forget about the limits right now. Forget about the limits right now. How do you solve this question? 3x cube minus 4x square plus 1 divided by, if I have root x means what? X power 1 by 2 dx. How do you solve this integration? So we will separate individual terms, right? Same thing we're going to do over here as well under the limits. Okay, so check this out. This will become 3x power what? 3 minus 1 by 2. So it will become 5 by 2. Correct now? 3 is going to be 6, right? 6 by 2 minus 1 by 2 is 5 by 2. Okay, minus 4 times of x power 3 by 2 plus x power minus 1 by 2. That's the whole term, number of terms. From where to where? From 0 to 1. From 0 to 1. Next step. Integration is done now. Please check. 3 as it is. Integrate x. It will become 5 by 2 plus 1. How much is that? 7 by 2. Divide by the same value. 7 by 2. Here as well. Minus 4 x power 5 by 2, because 3 by 2 plus 1 is what? 1.5 plus 1 is 5. Basically 2.5. That is what? That is 5 by 2. Divide by 5 by 2. Okay. Next what we have? Next we have this here as x power 1 by 2 divided by 1 by 2. Alright. So please check. This will become 6 by 7 x power 7 by 2. Of course, after the integration is over, right? The limit which was written over here 0 to 1, right on the right side of the square bracket 0 to 1. Okay. So this is done. 6 by 7 x power 7 by 2 minus 8 by 5, right? 4 into 2. 2 will go up now, guys. 2 will go up, right? This 2 will go up. So it will become 8. So 8 by 5 x power 5 by 2 plus, what is this? 2 times of root x. Correct? From where to where? From 0 to 1. When you put 1, what happens? It becomes 6 by 7 minus 8 by 5 plus 2. When you put 0, everything is 0. When you put 0, please check. If you put 0 over here, 0, x is 0 means whole thing is 0 in all the 3 terms. Okay. So you can solve for this and give me the answer. Solve this 6 by 7, 8 by 5 and plus 2 and give me the answer, please. All of you comment right now what's the answer for the question number 1. Calculation, right? So as I said, apart from the formulas and theories and the concept, you also have calculation involved in the case of definite integral. That is a must. Okay, super. Now next part. Next is what? Question number 2. Do not forget to give me the answers in the comment section. In the comment section right now. I want to see how many of you got it right. I think it should be around 44 by 35, something like this. Please check. Is it right? Please check. I'm not sure, but check it. I think 40 or something by 35. Have a look. Now is question number 2. Okay, there are roots involved. Of course, whenever we see roots, we either look for rationalizing or using a substitution. But don't use substitution right now because I'm not started yet. I'm gonna start that later in this session itself. Right now you can start with what? Rationalization, correct. So as I said, whenever we look at root, 2 things comes to our mind: how to make perfect square. And we can, if there's something is given over here, we'll do that. If not, we'll use substitutions. In this case, there's no way you can apply that over here. Okay, then use rationalization. This will become what? 1 times of root x plus 3 minus root x plus 2 divided by, please check, I'll get what? I'll have only x plus 3 root the square minus x plus 2 root the square in integration 0 to 1 dx. Please check. I'm using the formula a plus b, a minus b. Okay, a plus b was already there, right? Remember over here I'm multiplying with a minus b upon a minus b, so it becomes a square minus b square. A square minus b square. Very simple. What is this? we have numerator now as x plus 3 minus x plus 2 divided by, this will become x plus 3 minus x plus 2. Okay, so x and x gets cancelled and 3 minus 2 is 1. Alright, so it means there is no denominator left now. There is no denominator left now. Superb. Let's continue. The limit is as it is, 0 to 1. So 0 to 1 we have. Integrate individual terms. Root of x plus 3 minus root of x plus 2. I have this with what? With dx, both the parts. Here also we have dx. This becomes x plus 3 power 3 by 2 by 3 by 2. Here also minus x plus 2 power 3 by 2 by 3 by 2. Okay, substitute back the values. 0 1, it becomes 2 by 3 is a common outside. Please check. 2 by 3, this 3 by 2 and this 3 by 2 goes outside, right? Both of them becomes 2 by 3. I've taken that common, 2 by 3, and this value will be what? Put back here. You get 3 plus 3 by 2, right? Sorry, you get over here from 1 plus 3 becomes 4. 4 power 3 by 2 is how much? It will become simply 8. Please check. What is this? Put 1 over here. It will become 1 plus 3 is 4. 1 plus 3 is 4. So 4 power 3 by 2. 4 power 3 by 2 is what? 4 root is 2. 2 cube is 8. This is 8, sir. Okay. Same way. Now put 1 over here. You get a minus sign first. 1 plus 2 is what? Is 3. 3 power what? 3 power 3 by 2. 3 power 3 by 2. What is next? Next I have to use 0 over here. Again I get what? Minus sign will be there. This is the upper limit. Okay, this is my upper limit. Upper limit minus lower limit, right? So upper limit is done. I'm moving on to lower limit. Minus sign. Put 0 now. 0 plus 3 is how much? 3. Excuse me, it's not working. Something wrong. Okay, 0 plus 3 is 3 here. Power again 3 by 2 from here actually. Okay, and there's a plus sign over here, right? There's a minus sign over here. Now put back, in this case 0 plus 2 is simply 2 power 3 by 2. 2 power 3 by 2. Simplify this now, this whole thing. This is your answer. 2 by 3, this is 3 actually. 2 by 3 times of 8 minus, we have the same term coming over here, 2 times of 3 power 3 by 2, and we have plus 2 power 3 by 2. Okay, it becomes 6 root 2, sorry 6 root 3, and it will become 2 root 2, right? Yeah, 2 by 3 times of 8 minus 6 root 3 and 2 root 2. Please check. 6 root 3 and 2 root 2. I think the answer is 2 by 3 times of 8 minus 6 root 3 and plus 2 root 2. Please cross check. Is this correct? Please cross check, is this correct? Okay, this is the answer written over here. That's your answer. Have a look, guys. Question number 2 is over. Okay, as I said, there will be calculations involved in this kind of questions. Okay, so I had to take some water. Sorry. Let's start now. Sin 3x, sin 2x dx. Sin c sin d formula is there, right? Simply use 1 by 2 will come. Formula is for 2 sin c sin d. We'll have both cos's, so difference will be there first. Cos of 3x minus 2x will be x minus cos of sum. So 5x with dx, integrals 0 to pi by 4. Right? 1 by 2 is outside. Integrate now. Cos of x is what? Sin of x. Cos 5x is what? Cos 5x is sin 5x by 5. What's the limit? 0 to pi by 4. Limit is 0 to pi by 4. Correct, na? Formula 2 sin c sin d or 2 sin a sin b. It becomes cos of a minus b. Sorry, cos of a. Yeah, cos of a minus b and cos of a plus b. Okay, correct. So the integration of cos x is sin x and cos 5x is sin 5x by 5. Superb. Have a look. I have 1 by 2 outside. Sin pi by 4 is going to be 1 by root 2. And over here I have 1 by 5 outside. Sin of 5 pi by 4. Right, I'm putting the upper limit over here. Sin of 5 pi by 4. Which quadrant? 5 pi by 4 is more than pi, so third quadrant. Sign is negative. Will become minus 1 by root 2. Okay, this is my upper limit. This whole thing is my upper limit. There comes a minus sign for the lower limit. Please check x as 0. Sin 0 is 0. Sin 0 is 0. Next what? Sin 5 into 0, again 0. This whole thing is also 0. This is my lower limit. Okay, let's continue. I'm getting here 1 by 2 is outside. 1 by root 2 plus 1 by 5 root 2. Okay, 1 by 5 root 2. LCM, I can take it outside as 2 root 2 is common. Excuse me, I'm taking root 2 common. Okay, so I get 2 root 2 over here. This root 2 and root 2 is taken common. I get 1 plus 1 by 5. How much is this? It becomes 1 upon 2 root 2. It will become 5 plus 1, 6 by 5, right? My answer is, cancels here, 3 by 5 root 2, no? Please cross check, guys. Is this correct? 3 by 5 root 2? Is this the answer? Or have I made any mistake in this question number 3? Calculations. Have a look. Question number 3 is done. Question number 4 now. 1 minus sin 2x 0 to pi by 4. Now from here onwards you have to use the identities, of course. Sin 2x is what? Sin 2x is 2 sin x cos x. What is 1? 1 is cos square x plus sin square x. The identities, right? Sin 2x minus 2 sin x cos x. This whole thing is inside the root. What I get from here? Cos x minus sin x to the power 2. Power 2 in the root. Okay, what I get? 0 to pi by 4. What is this? This is cos x minus sin x in the modulus. Why in the modulus? Because if you're taking root, no, both plus and minus sign can come. Okay, both plus and minus sign can come. This mod, so this root and the square root will cancel, right? Inverse of each other. So they will have plus and minus sign, cos x minus sin x. What's the limit? 0 to pi by 4. Check this out. Graph you check. Cos is over here, sin is over here. This value is what? Pi by 4. Upper part is cos and the lower part is sin. All of you know cos is more than sin. Cos is, check this graph, cos is above sin. From where to where? From the interval 0 to pi by 4. What is the interval given to you? 0 to pi by 4. Limit is 0 to pi by 4. It means that this will become positive. So I'll have answer as 0 to pi by 4 cos x minus sin x. Now you might feel that this is useless. Not required, sir, because it's same thing, no? What if the limit was different? What if the limit was different? Then what will happen? Understand this. Whenever you integrate, no, you only talk about the positive values. Okay, so you have to break the integration properly. When I go and teach you properties of integration, I'll discuss that part over there. I've taken a question like this. Okay, so if it was, let's say, 0 to pi by 2, understand, it's very important. If it was 0 to pi by 2, what will happen then? What will happen then is basically I have to break this into 0 to pi by 4 cos x minus sin x and plus I have to go from what is this, pi by 4 to pi by 2 sin x minus cos x. I'm telling you, not in this question, not in the given problem, but if there is a situation where it is 0 to pi by 2 and you don't take the mod, you directly take what? Directly take the value as cos x minus sin x, answer will be 0. Answer is wrong. Because since you have from 0 to pi by 4, cos is higher. Good. You're going to take cos more than cos x minus sin x. But next case, from pi by 4 to pi by 2, sin is more. Please check from here. Sin is upper. Sin is above. Okay. Sin is higher. It means that, of course, you have to take sin above. Okay. This is just example to understand, not a particular case as such. But I hope you get the point. Okay. So let me remove this. Just because I'm giving you this explanation because of only one reason. And what's the reason, sir? If you are, one of you are thinking that, sir, we don't need the modulus sign. I'm telling you, you're wrong. You must use the modulus sign to understand the graphical part, the nature part. Okay. Yes, in this question, there's no need because it's automatically positive. Cos is more than sin x. But if it is not positive, then there will be sign change. Then your answer will be wrong. Very important to use the modulus. Please make sure that you understand that. Okay, now integrate. Cos of integration is what? Is sine. So sine x I get over here, and for sine I'll have what? Minus cos. Integration is over from where to where? Limit is given 0 to pi by 4. Right now, cos integral is sine, sine integral is minus cos. I've written that, and limit is 0 to pi by 4. What I'm getting here? Sine x plus cos x from where to where? 0 to pi by 4. Use it. For pi by 4 I'll have 1 by root 2 plus 1 by root 2. This is both upper limit. This is both upper limit. Cos pi by 4, sin pi by 4. Both are 1 by root 2. For 0, our lower limit you check. Sin 0 is 0 and cos 0 is 1. What is my answer? 1 by root 2 plus 1 by root 2 is what? Is 2 by root 2. And we have minus 1. My answer is 2 by root 2 is what? Root 2 minus 1. My answer is root 2 minus 1. Please check. 1 by root 2 plus 1 by root 2 is 2 by root 2. And we get the answer as simply root 2. Root 2 minus 1 is the final answer. This is my final answer. Root 2 minus 1. Let me block it so that it's easy for you to understand and visualize from here. Root 2 minus 1 is my final answer. Done. Getting it? Very important, guys. Because even in the case of AOI, the two questions which is coming from application of integrals, this definite integral plays a big role in there. Okay, so very, very, very important. Dx upon 1 plus cos 2x. Dx upon 1 plus cos 2x. How do you solve this question? How do you solve this particular problem? Okay, so please check. I have a formula for this. 1 plus cos 2x, there is a formula. All of you remember? 2 cos square x. 1 plus cos 2x is 2 cos square x. If it was 1 minus cos 2x, it will become 2 sin square x. There's a difference, okay? So we can use this. 0 to pi by 4 dx upon 2 cos square x. I think now all if you can visualize, right? 2 will come outside, 0 to pi by 4 remains as it is. 1 by cos square will become sec square x dx. 1 by 2 remains outside. Integration of sec square. Integration of sec square is what? Tan. Yes, superb. Very good. If you know all of this, superb. Good job. From where to where? 0 to pi by 4. Superb here. I'm getting here 1 by 2. It's going to be tan of pi by 4 means 1 minus tan 0 is 0. So I get answer as 1 by 2. Option A is correct. Fifth one, option A is correct. Fifth one, option A is correct. Got it? Question number 6. It's a simple question, exponential question, right? We have e power 2 minus 3x, okay? Integrating this from 0 to 1. That's the question. I hope this is visible. Yeah. So integrate this, you're going to get what? It remains as it is. 2 minus 3x will be as it is. Divided by minus 3, sir. Divided by minus 3, sir. Okay. From where to where? From 0 to 1. The limit is 0 to 1. Superb. Take the number outside. Minus 1 by 3 is outside. Put the upper limit e power 2 minus 3, because 3 into 1 is minus 3. Okay. And lower limit will come e power 2 minus 0. Right? When x is 0, x is also 0. What I'm getting here? Minus 1 by 3 e power minus 1, e power minus 1 and e power 2. E power 2. What is my answer? E power 2 minus e power 1 by 3. Please check. Option B is correct. How come? Because if you check here carefully, 1 by 3 is negative here. Here we have 1 by 3 positive, and the sign is just alternate over here. E square minus e power minus 1. Here we have e power minus 1 minus e square. So you can check. This is same as the option B. Clear? Simple question. This is very simple, right? Yeah. Now we are starting with one of the most important subtopic of the unit, definite integral. Okay. All of this is there but not required. This is the most important part. Put here 3 star. Is it enough? No. Put here 5 star. Is it enough? No. As many star you want to put here. This is the most important part of this chapter, of this subtopic of substitution method. Whenever you are, understand this statement very clearly. If you are making any substitution, you have to change the limits as well. change the limit as well. Okay, so if you are making any substitution, tan x as t, sin x as t, whatever it is, change the limit, because in the original question they must have given you the limits for the sin x, right? But now you're taking sin x as t, then the limit has to be changed for the variable t, not x. Let's say they are saying that for sin x the limit was given from 0 to pi by 2. That's my limit, okay? But you're taking this as t. What will happen? It will become 0 to 1. Because when x is 0, sin of 0 is 0. You have taken what? You have taken sin x as t, right? When x is 0, sin 0 is 0, so t is 0. Lower limit, upper limit. X is pi by 2. What happens? Sin pi by 2 is 1, so t is 1. So whenever you are changing the function, but with the help of substitution method, you have to change the limits as well for the variable. That's the most important point you need to remember if you're using the substitution method in definite integral. Otherwise, I'll tell you what, if it is possible, if it is simple, try to do the entire integration in the form of indefinite only, and at the last obtain the original variable and use the limits. In sometimes actually this also will be faster. Understand this. Let's say the original given function is in terms of the variable x. The limits will be given for the variable x, right? Then what you can do is do the entire process, get substitution, everything, write the final answer in terms of the variable x only. Switch back, and finally use that same limit or change the limit. Okay, please check. When x is a, t is ga. When x is b, t is gb. This is the change of limit. This represents change of limits with respect to what? With respect to the variable t. With the variable t. Okay, this all you already know, right? If you're taking gx as t, you have to take derivative of gx dx with dt. You know this much. This much you know. You have learned this. I've taught you this in the method of substitution in indefinite integral. We'll have more clarity when we see a question. Okay, x square upon a square x square power 5 by 2. Now I have given you a list of substitutions. In what cases, which one to use. If you watched my previous session, you will know which one to use over here. X is tan. X equals to a tan theta. X equals to a tan theta. Super. So if you differentiate this, you're going to get what? Dx. Here you'll have a sec square theta d theta. Correct, because this will be x will be 1. You'll have this side as d theta by dx. Dx will come over this side. Okay, superb. I have dx. I'll replace that by this value. One job is done. Okay. Okay, sir. Apart from that, limit change. When x is 0, please check from here. You'll have a tan theta will also be as 0, no? Okay. When x is 0, you get theta value as what? 0 only. Theta value will be also 0. Okay. What about this? When x is infinity, when x tends to infinity, you will have infinity by a, infinity only. Tan inverse will be pi by 2. Will be pi by 2. I hope you're getting it right. If not, please check. What I'm doing actually here is I'm writing x by a tan inverse as theta. X by tan inverse as theta. Okay, please check. X, if you put 0 over here, 0 by a is 0. Tan inverse of 0 is what? 0. That's why theta is 0. Put here infinity. Infinity by a is infinity. Tan inverse of infinity pi by 2. Clear? How I am changing the limits is clear, right? Now check the integration that I have made over here. This changes to integral of 0 to pi by 2. 0 to pi by 2 up lower limit, upper limit. Okay, 0 to pi by 2. Function x square means a square tan square. A square tan square theta. This becomes what? A square plus a square tan square theta power 5 by 2. Power 5 by 2. Dx means this whole thing. A sec square theta d theta. That's my dx. Right from here. Superb. Let's carry on. Let's carry on now. So continue from here. 0 to pi by 2. Okay, now check this out. I can take something common here. I'm getting this as, first of all, a cube is there. We have tan square theta sec square theta d theta divided by, check this out, I can take a square common. It will become 1 plus tan square theta, and this whole thing is under 5 by 2 power. Okay, if I do that, I'll get this as sec square theta. It will become a square sec square theta power 5 by 2. So this 2 and this 2 will cancel with both the 2's. Okay, so I get a sec theta power 5. Okay, I'm going to replace this whole thing, the denominator, by a power 5 sec power 5. Please check. I'm going to replace the whole thing by a power 5 and sec power 5. I'm erasing this all. Writing again over here a power 5 sec power 5. Please check. Okay, this will become what? A power 5 sec power 5. Super. Sec power 5 theta. A cube cancels this with a square. Okay, sec square also cancels with 3 over here. And what I have now? I have here pi by 2 from 0. 1 by a square is a constant outside. Okay, tan square will become what? It will become sine square theta by cos square theta, and we have 1 upon, sorry, I have cosine sec cube, right, in the denominator. I have sec cube. It will go up as cos cube theta d theta. Cos cube theta d theta. Please check. I had sec power 3. It will become cos 3. So this will cancel. Now what I have sine square cos theta. I have sine square cos theta. What I'm going to do? I'm going to do what? I'll have to make one more time substitution, sir. One more time substitution, sir. Okay. Next substitution is what? Sine theta equals to t. What I get for this case now? I get cos theta d theta equals to dt. This will become dt. Okay. And limit change now one more time. When t is 0, when theta is 0, t also is 0, sine 0 is 0. Put here, when theta is 0, sine 0 will be 0, so t is 0. Okay, and when theta is pi by 2, t becomes 1. Have a look. I am taking sine theta as t, right? When theta is 0, sine theta is 0, so t is 0. Theta is pi by 2, so sine pi by 2 will become again 1, so t is 1. Alright, what I get from here? I get 1 by a square t square dt. From here I get 0 to 1. The limit is changed now. Limit is changed now from 0 to 1. Okay, t square, this is dt. What is the value? 1 by a square. This will become t power 3 by 3. Okay, from where to where? From 0 to 1. At 1 it will be 1 because we have t cube over here, and for 0 it will be 0. My final answer is nothing but 1 by 3a square. That's my final answer. Please check. When you put t value as 1, it becomes 1 by 3. So 1 by 3a square. When you put lower limit 0, it will become 0 by 3 is 0. 0 into anything is 0. I get simply 0. Answer is 1 by 3a square minus 0, which is what? 1 by 3a square. Have a look. Clear. 7th is over. Question number 8 now. 0 to pi by 4 dx upon cos cube x to sin 2x. Okay. Super. We'll see this part. We'll see first. Forget about the question right now. We'll just simplify this. I have cos cube x, and inside I have 2. I have sin 2x means I have 2 sin x cos x. Correct. 2 is already there, and sin 2x also has 2 sin x cos x. Okay, this is sin 2x. So what I get? This will become cos cube x. 2 into 2 is 4, so 2 will come out. I'm writing it over here, the constant, and this will become what? Sin power xy, sin x power 1 by 2. Excuse me guys. We'll have sin x over here, power 1 by 2, and they'll have cos x power 1 by 2. Okay, combine these two together, I get 2 cos of power 7 by 2, cos of x power 7 by 2, sin x by 2 is there, sin x power 1 by 2 is there. Please check. If I'm writing here tan of x power 1 by 2, this will become sin of x power 1 by 2 upon cos of x power 1 by 2. I have over here what? Sin of x power 1 by 2. So cross multiply these two. What I'm getting? I'm getting here as tan of x power 1 by 2 into, excuse me, into cos of x power 1 by 2. Got it? So I have done the simplifications over here and written sin x in terms of tan. So I'm getting a tan of x power 1 by 2 and cos remains as it is. Please check. Combine these two. I get 2 times of cos of 7 plus 1, 8 by 2x and tan of 1 by 2. This is 2, okay? What I get for this? Twice of cos power 4x, and this is basically root tan x. Root tan x. Okay. Now check this out. So basically I can change this now. I can write this again. I can write this whole thing over here again, this whole integration over here again, as integral from 0 to pi by 4. This all is nothing substitution, okay? This is simply, simplifying the entire given term. There's no substitution done over here till now, okay? Now we'll see. So we have 1 by 2 is a constant, keep it outside. This 2 is a constant. Was it in the denominator, right? This whole thing is in the denominator. 2 is constant taken outside. I get 1 by cos power 4x root of tan x of course dx. Now see this, I have 1 by 2 over here, 0 to pi by 4, 1 by cos will become what? Sec square x into sec square x dx upon root of tan x, correct? What I've done? I have cos power 4 over here. This whole thing goes up, it will become sec power 4. I'm writing sec power 4 as sec square into sec square. I can do that. I can do that. Yes. Check this out now. This will become dt. If I take tan x as t, this sec square x dx will become dt. Superb. Now the limit change. When x is 0, tan x is t. Means when x is 0, t is 0. Please listen me. When x is 0, tan of x will be 0. It means t is 0. When x is pi by 4, t is what? Tan pi by 4. How much is that? 1. Limit change. 1 by 2 is outside. Integration from where to where? 0 to 1. Sec square means what? 1 plus tan square means 1 plus t square. This is dt upon root t. Upon root t. I think you can do this integration now. Please check. Sec square is what? 1 plus tan square. What is tan square? T square, because tan x is t. Separate this, you'll have t power what? T power minus 1 by 2. And over here you'll have t power 3 by 2. Please integrate this part. Integrate this from 0 to 1 with the constant 1 by 2 outside. Solve it. Please solve. You have a number over here. Solve this step, okay? Comment your final answer. Comment your answer for question number 8. Final answer. I've given every step that is required to solve this question. You need to just do the calculation part. Okay? Integrate here. It will become t power 1 by 2. It will become t power 5 by 2. Put the value of 1 and 0. Give me the final answer. Question number 8. I want the answer from all of you. I want to see how many of you are actually listening, learning, and solving the problems. Okay? 8th is done. 9th now. Question number 9 now. Cos 2x log of sin x. Superb question. Cos 2x log of sin x. Okay, check this out. How to solve this? Cos 2x log of sin x. Of course we're going to use what? By parts here. We'll use by parts here, sir. So there the question becomes sometimes tricky. Not tricky, actually lengthier, if I want to say that, right? Okay. Okay, we have the preference order for by parts. ILAT. So log ILAT is there the preference order. So algebra has the preference over trigonometry. Okay. Sorry, log has preference over the trigonometry. Yeah. So I'll keep log sin x as it is. Log of sin x as it is. Integrate cos 2x. You're going to get what? Sin 2x by 2. Excuse me. This is over, right? Integration is done for this part. I get from where to where? Pi by 4 to pi by 2. Minus sign will come. The second part of the by parts equation result. Differentiate the log. You'll have 1 by sine. We'll have 1 by sine. And sine will be cos, right? Basically cos by sine. Correct? Please check. Derivative of log sin x will be 1 by sin x. Again chain rule will be applied. Becomes cos x in the numerator. So cos x by sin x. This remains as it is. Sin 2x by 2. And we have of course dx for the next integration. Okay, good. Good enough. Apply this pi by 2. If you put here, sin pi by 2 will be 1. So this will become 0. Log sin pi by 2. 1. Log 1 is 0. Log of this sin pi by 2 is 1. Log 1 is 0. So for upper limit is 0. At pi by 2 this whole thing is 0. Let's look at now at pi by 4. So what I have for this? I'll have minus sine for the lower limit. Log of sin pi by 4. How much is that? 1 by root 2. 1 by root 2. Am I correct? Yeah. Now comes into over here. You'll have what? You'll have over here as sin 2x by 2, right? So sin pi by 2 will become 1 by 2. Correct? Correct? Please check. This 2 is there and sin 2 into pi by 4 will become pi by 2. Sin pi by 2 is 1. So I have 1 by 2. Okay. This is my this term. Over here now, minus sine is there. Cos x by sin x is there. Sin 2x will become what? 2 sin x cos x by 2. 2 gets cancelled. Sin gets cancelled. We have of course dx over here. This part I have minus sine and I have log. Okay, 1 by 2 is a constant. I'll keep it outside. 1 by 2 is outside. And we have this is outside. Okay, separate. This is multiplied to log. It's not part of the log actually. This 1 by 2 is multiplied to the log. Can be taken outside. Okay, so I've taken the 1 by 2 with the minus sign over here outside. All right, I get log of 1 minus log of root 2. How come? Property of log. Log a by b. I have log 1 upon root 2. It becomes what? Log of 1 minus log of root 2. Superb. Integration of cos square x dx. Understood? So far, so much. Yeah. Check this out now. Minus 1 by 2. Log 1 is 0. Minus log of, what is this? Root 2. Over here we have minus integration of cos square x dx. Next step, it will become plus 1 by 2 log of root 2 means 2 power 1 by 2. This will be what? Minus sine 1 plus cos 2x by 2 dx. Right? Cos square is nothing but 1 plus cos square, 1 plus cos 2x by 2. Have a look. This 1 by 2 will come in the front. It will become plus 1 by 2 into 1 by 2 log 2 minus sine. 1 by 2 is a constant keeping outside. 1 plus cos 2x dx. Over here we have 1 by 4 log 2 minus 1 by 2. I get here x, and for this I'll have plus sine 2x by 2. Correct? Plus sine 2x by 2. Okay, I forgot the limit, right? Limit was there, no? From here also we had everywhere the limit was there. I forgot to write. This limit is there, okay, over here, all the limits are there. I forgot to write the limit. I'll write it over here, the last step. It's here, everywhere it's there. Pi by 4 to pi by 2, here also. Pi by 4 to pi by 2, here also. Pi by 4 to pi by 2. Okay, we'll see the steps of the limit in the last. Okay, so far I have what? I have 1 by 4 log 2, and then we have minus sign. 1 by 2 is outside, right? Yeah, and we have x plus sine of 2x by 2. Is it right? Yeah, and we have pi by 4 to pi by 2 is the limit. Let's substitute the limits now for the second part. Okay, so I have here log 2 by 4 minus 1 by 2. If you put here, you get pi by 2 upper limit plus sine of pi by 2 by 2 will become 0, right? Please check. Sine 2 times of pi by 2 will be simply pi. Sine pi is 0. That part is gone. Minus lower limit now. Pi by 4 will become what? Simply pi by 4. And this time we'll be having what? 2 times of pi by 4. Sine of 2 times of pi by 4. Sine of 2 times of pi by 4. How much is that? Pi by 2. 1. So what I have over here? Plus 1 by 2. Please check. Right? Am I correct? Yeah. Yes. Okay. So I have here log 2 by 4 minus 1 by 2. I have pi by 2 minus pi by 4 minus 1 by 2. Correct? What I get for this? I'm getting over here as pi by 4 only. So I have log of 2 by 4 minus 1 by 2 times of pi by 4 minus 1 by 2. I hope you know the answer now. It is going to be what? My final answer is log 2 by 4 plus pi by 8 plus 1 by 4. This is minus, okay? This is minus. My answer is log 2 by 4 minus pi by 8 plus 1 by 4. Yes. Done. Ninth one. Okay. Have a look. Yes, the questions will be a little lengthy, calculative. You can build the pace after start doing. After you start practicing this question more and more. And don't worry, I'll come up with a session where I'll talk about the shortcut tricks for the chapter integration as well. Okay. So yes, these questions are a little challenging, little bit lengthier, but that's how it is. The tricks I'll give you. I'll give you the tricks to solve these questions anyway. Okay. Wherever tricks are there to solve the question in integration, certainly I'll give you. Okay. Now, 0 to pi by 4 tan cube x sec square x. This is a simple question, right? This is simple. Take tan x as t. You get sec square x dx as dt. Substitute now for the limit. When x is 0, t is tan of 0 means 0. When x is pi by 4, t is 1. Tan of pi by 4 will be 1. This whole thing becomes what? 0 to 1 t cube dt. This is dt. This is dt. Okay. So we have t power 4 by 4. From where to where? 0 to 1. 1 by 4 is a constant outside. Put 1 minus 0. Answer is what? 1 by 4. Option A is correct. Please check. Option A is correct. This is a simple question. So not all will be difficult, okay? But yeah, fewer when you're using by parts or a very good amount of substitution, then it will be difficult in nature. Question number 11 now. This is a simple question. This is a very simple question, okay? Have a look. I have 1 plus e power x over here. Of course, that is my substitution, right? 1 plus e power x as t. Differentiate. You will have e power x dx as dt. This whole thing in the numerator is what? Is dt. Now the limit change. Do we need to? I don't think so. We need to. We'll not do that. We'll come back to the limits because it is easier this way. You see, forget the limit right now. Just like this, you write dt by t. What is the answer? Log t. Correct. This way is easier. Do not have to worry about limits right now. This way is easier. Log t is my answer. Okay, now you're going to put the substitutions. What is t value? To put back the original limit given to you, you have to put back the original variable also, right? What is the t value? E power x plus 1. Now you're going to put the limit in this condition, because they have given the limit for the variable x, and you have put this back in the terms of variable x. E power x is there, right? So 0 to log 2. I have put back the original limits. Please check. This becomes log of, have a look, e power log of 2 plus 1, that's my upper limit. Okay, that's my upper limit, minus lower limit will be what? Log of e power 0 plus 1, right? What I get, e power log 2 is simply 2 to 2 plus 1, and log of e power 0 is 1, 1 plus 1. Okay, I get log 3 minus log 2. What I get? Log of 3 by 2. Log of 3 by 2. Answer is option number C. Please check. The question number 11 is simpler to solve without changing the limits. So what I've done, I've solved the entire integration with the help of simply doing it as the substitution method without the use of change any of the limits. Finally get back the final answer in terms of the original variable, which is x in this case, and use the same limit that you had in the given question. 11th one is over. Question number 12 now. Question number 12 now. Find 0 to pi by 2, 1 upon 1 plus 3 cos square x. Whenever you see cos square in the denominator, no, the hint is use division by cos square. It'll change the entire question. See, it'll become 1 by cos square of x. We'll have over here 1 by cos square of x plus 3 dx. Check this out. It'll become sec square of x, sec square x dx upon sec square x plus 3. Okay, now write sec square of x as tan. So I get sec square of x dx numerator as it is. This will become what? Tan square x plus 1 plus 3. We all know sec square is what? Tan square x plus 1. Okay, alright. Limit is what? 0 to pi by 2 everywhere. This is 0 to pi by 2 here also. Okay, continue. What I'm getting now? I'm getting this as tan square x plus 4, right? To take this substitution as tan of x as t. Substitution is tan of x as t. My substitution. Differentiate. I get sec square of x dx as dt. Limit change. When x is 0, what happens to t? T is 0. Correct? Tan of 0 is 0. T is tan t, tan x. When x is pi by 2, t is going to be infinity, because tan pi by 2 is infinity. The limit changes. 0 to infinity, dt in the numerator, and over here we have t square plus 4. Correct now? 3 plus 1 is 4. Formula is there for this. 1 by 2, 1 by a, tan inverse of t by a. So t by 2. From where to where? 0 to infinity. Have a look. 1 by 2 is a constant, keeping it outside. Tan inverse of infinity minus tan inverse of 0. What I get for this? 1 by 2, this is going to be pi by 2 minus 0. Answer is pi by 4. Option B is correct. Right? Please check, this is the formula. T square plus 2 square. A is 2 square. 1 by a tan inverse of t by a. Infinity will be pi by 2. 0 will be 0. Pi by 2 into 1 by 2 is pi by 4. Option B is correct. Option B is correct. 12th one is also over. Have a look. Okay, 12th one is also done. Now we are moving to the last topic of the chapter, integration as well as definite integral, which is properties of definite integrals. Properties of definite integrals. Okay, I have some more questions I want to solve, but after this topic. There are a total of 7 properties, the 7 most important ones. We'll go through them one by one. Property number 1. Property number 1, again this is something which is there in your NCERT. If you want, you can open from there also. Okay. Property number 1, a to a f of x dx will be 0. How come? Let's say f of x dx integration is what? Gx. From where to where? A to a. It will become g of a minus g of a. How much is that? 0, right? So if you are integrating a function from the same value a to a, answer is always 0. Okay. If you have the limit over here a to b, I can write this as b to a also with a minus sign. You can switch the limits with the help of a minus sign always. Property number 2 also done. Property 3, if you have a to b function fx dx, you can change the variable of the function anytime without any change in the limits. Check here. Fx becomes ft, dx becomes dt. Limits same. Functions variable can be changed without changing the limits. 1 second, guys. Sorry, had to take some water, my bad. Okay. Yeah, property 3 was done, right? I can change the limits, sorry, without changing the limits, I can change the variable. Property 4, if you have the limit from a to b, I can keep breaking it down any amount of times. See, a to c, c to b, I can go a, c to d, d to b, means you can break it at any amount of time, provided that this a is your first lower limit and this is your upper lower limit. Okay, and any variable you are taking, c, d, whatever it is, should be greater than a and less than b. If I take, let's say, d also, it should be d less than b. I want to take e also, should be greater than d and less than e. Okay, order should be like this: a to c, c to d, d to e, e to b. Any number of time you can break the function depending upon your need. Okay, if you have limits given like this, understand this: first lower limit should be a, last upper limit should be b. 0 to 2a can be written, this is the property 5 based upon property 4 only. 0 to a fx dx and 0 to a f of 2a minus x dx. Okay, same thing. Next, property 6 and 7, the most useful, not most useful I would say in exam, no, actually the last two and this one, even this one, to prove the sum of the properties in boards becomes very important. So property 2, property 3 and property 6 and 7 are the most useful one. Actually all of these are, I'm biased. Even the fourth one question will be directly asked in AOI. When you're learning this chapter, no? AOI, you will have question property number 4 used most of the times. Then will become the most important property, property number 4 in the case of applications of integrals. Okay. Alright, so property number 6 is based upon even and odd functions. If you have a function defined here, even, and the limit is from where to where? Minus a to a. Basically, for example, minus pi by 2 to pi by 2, minus 2 to minus 2, whatever it is. If the limit is like this, fx dx is there, fx is even function, the answer will be simply twice of 0 to a. You can split the limit, no? Minus a to 0 and 0 to a, sorry, 0 to a, and write this as twice of 0 to a, twice of 0 to a. If it is odd, if the limit, if the function given to you is odd, basically what it means, odd function, f of minus x is minus fx. For example, sine of minus x is minus sine x. It means sine is an odd function, whereas cos is an even function. Okay, so basically, whenever you're dealing with the case of odd functions and the limits are like this, minus a to a, answer is always 0. Answer is always 0. Very, very useful. Property 7, a to b fx dx. Okay, if you have limits given like this, again very, very useful in the questions. We'll see right now properties. There's a trick defined for this as well. We'll see that as well. Okay, a to b, simply add the limit a plus b minus x. So you can replace this value, the variable x, from here to here as a plus b minus x. Replace this x as a plus b minus x under the same limit. Limit remains same. Okay, clear? Now questions on the properties that we have learned. Cos inverse of x. How do you solve this? Very simple, sir. Cos inverse of x as t. So x as cos t. So dx will become what? Dx will become what? Minus sin t dt. Okay, that's my dx over here. This will be t square. Limit change now. When x is 0, t is 0. Okay, sorry, t is 0. No, pi by 2, no, pi by 2. Cos inverse of 0 is pi by 2, not 0. It's not sin inverse, right? Forgive me guys, it's pi by 2. And when x is 1, t is 0 actually. Cos inverse of 1 is 0, cos 0 is 1, right? The cos inverse of 1 is 0, and cos inverse of 0 is pi by 2. Put here x value as 0, you'll get t value as pi by 2. Put x value as 1, you'll get t value as 0. Okay? Check the integration now. It becomes pi by 2 to 0. We have here this as t square. This will be what? Minus sin t dt. Bring the minus sign outside, it will become minus t square sin t dt. Okay, and this will be what? Pi by 2 to 0. Pi by 2 to 0. We just learned if you have a minus sign, you can switch back the limits. Okay, if you have minus sign, we can switch back the limits. This will become what? 0 to pi by 2 t square sin t dt. What is the step over here? Of course, by parts, right? Of course, by parts. AT, algebra has a preference, right? So we're gonna keep this for as it is. Integrate sign will become what? Minus cos t. From where to where? From 0 to pi by 2. Minus sign will come. This time what you're gonna do? Integrate with the differentiation of t square. You'll have 2t. Integrate sign again. You'll have minus cos t dt. Please check. Pi by 2 if you put in cos, it will become 0. Cos pi by 2 if you put, I'm putting the upper limit, lower limit. Cos pi by 2 will be 0. This is whatever it is, doesn't matter. Whole thing is 0. When you put 0, t square means 0 square, again 0. This whole thing is 0. This whole thing is, this first term is 0, sir. What about this? We have a minus sign. Minus and minus becomes plus. So plus 2 times of, we have t cos t dt from the same limit, 0 to pi by 2. 0 to pi by 2. Now we're going to do one more time by parts. Please check. For t, we'll keep as it is. Cos will become sin t. Limit will be same, 0 to pi by 2. This 2 is outside, okay? We'll have for both the terms. This 2 will be there for both the terms. This 2 is outside. 2 is outside. Superb. We have here minus sign. Derivative of t is 1. This will remain as it is as sin t dt. Okay. All right. Limit remains same, 0 to pi by 2. Okay. Just last few steps. We get twice over here. What is the bracket leading me to? Have a look. When you put pi by 2, will become what is it? Sin pi by 2 is 1, right? So I get pi by 2 into 1 is pi by 2. And sin 0 will be 0, right? Correct. Put pi by 2 over here. This is pi by 2. This will be 1. So I get pi by 2. Otherwise, it will become what? 0. 0 into anything is 0. This is gone. First term is dealt with. Next is what? I'll have integration of this will become again minus cos. So we'll have minus cos t from where to where? 0 to pi by 2. Okay. One last step. I get pi by 2 left over here. This will become plus sine cos t from where to where? 0 to pi by 2. Twice of pi by 2 minus, sorry, plus. Cos pi by 2 is 0. Cos 0 is 1. Please check. Have a look. Here. Cos of pi by 2 is 0. Cos of 0 is 1. What I'm getting? Twice of pi by 2 minus 1. Product of this will become pi minus 2. That's my final answer. That's my final answer, pi minus 2. Please check. Question number 13 is over, guys. Question number 13 is over. Have a look. All the steps are clear. All the steps are clear. It's not a difficult question, is it? No. 14 now. Question number 14. Okay. So we have again user properties. User properties one more time. This time we're going to use in the first part this property. Actually, there's a trick. There's a trick actually in this kind of question. So whenever you can find that, if you add limits 1 plus 2, subtract the variable x, what is going to be? This is going to be 3 minus x. So replace the x wherever it is as 3 minus x. Replace x as 3 minus x. If you do that, please check carefully. It will be the same thing. You'll have this will become x, this will become 3 minus x. Whenever you have that, please check carefully, even the numerator will become the same thing when you add those two. I'll show you that, but don't worry. But actually answer becomes what? 2 minus 1 by 2. That's my answer. Answer is 2 minus 1 by 2. What is the answer? Upper limit minus lower limit by 2. That's my final answer. In this case, please check. 2 minus 1. 1 by 2. That's my final answer. That's a trick. Whenever you have a question like this, where this is same, after changing it, it remains same. I'll show you. Now rename this integration as I from 1 to 2 root x upon 3 minus x plus root x dx as equation number 1. I've taken this integration as I. In the same integration, I'm going to change this using this rule. Remember the property? I'll change x as 3 minus x. What is 3? Sum of the limits, 1 plus 2. Under the same limits. So integration will change or not? No. Integration will also remain the same. Limit will remain same, 1 to 2. It will become what? X will become 3 minus x. Check carefully. This part will become 3 minus x. Over here, this will become simply 3 minus x dx. Carefully, if you understand this, what you have 1 by 2 root of 3 minus x, okay, divided by 3 and 3 will cancel, only root of x is left. Only root of x is left. What about this? 3 minus x is left. Okay, sorry, this is plus sign. My bad. This is plus sign, okay? Equation number 2. Add equation 1 and 2. Add equation 1 and 2. What are you going to get? I plus I. How much is that? 2i. Limit will be same, right? Check the denominator is same thing. Root of x plus root of 3 minus x. Same thing. Root of 3 minus x and root of x. Over here also. Root of x and root of 3 minus x. What about numerator? This plus this. Right? Because the denominator is same, means I can add the numerator as it is. Check carefully, this is the same thing. Cancelled. Just dx is left. Just dx is left. Have a look. Basically, this whole thing is becoming 2i equals to integration of 1 to 2 dx. Yeah, 1 to 2 dx. Alright, I was on the question number this, right? Okay. Have a look. I'm getting this as integration as, what is it? X from, okay, 1 is done, no? Integration is over, right? If I write x means integration is over. From where to where? 1 to 2. Have a look. I'm getting 2i equals to 2 minus 1. So I'm getting 2i equals to 1. It means my integration I is nothing but 1 by 2. Done or not? Why I, sir? Because same thing is, I've taken this as I only, right? Have a look. This is taken as I only. It means my I value or this integration value is coming out as 1 by 2. I've taken that over here. So you can write all the steps. So remember this trick. What's the trick over here? Whenever you can see a system like this where this is cancelable, answer is upper limit minus lower limit by 2. Always upper limit of the integral minus lower limit of the integral by 2. 14th part 1 is done. 14th part 2 now. 14th part 2. We have 0 to 1 log of, what is this? 1 by x minus 1, I think, right? Please check 1 by x minus 1. Of course, there's a dx, of course. Check this out. We have 0 to 1 log of 1 minus x upon x dx. Log of 1 minus x upon x dx. Alright. Let's do one thing. In this case, I'm going to assume this to be my integration number I again. Integration I with the first equation. Same approach. X will be replaced by the limits 0 plus 1 minus of x. How much is that? Simply 1 minus of x. Replace x wherever it is by 1 minus of x. I get 1 equals to, limit is same, log of 1 minus of x divided by 1 minus of x. 1 and 1 is cancelled. I'm getting here, this is nothing but 0 to 1. Log of x upon 1 minus of x dx. Alright. So what I get now? I get integration as, please check, 0 to 1 log of, okay, I can take this now from here only. I equals to equation number 2. I equals to equation number 2. Please check. 0 to 1 log of x upon 1 minus x dx. Here it is same thing. Add them. Add equation 1 and 2. Add these two equations. Limit is same. You can add log, right? Log a plus log b. It will become log of a minus b. Sorry, a into b. How come, sir? How come this whole thing? Log of a plus log of b. Adding the two logs, it will become log of a into b. Check this out. This cancels, this cancels. I have 0 to 1. Log of nothing means 1. What is my answer? 0. 2i is 0 means what? I is also 0. Correct, no? Log of 1 is what? Log of 1 is 0. If this whole thing is 0 means you can't integrate it anymore. Answer will be 2i equal to 0 means I is 0. That's your answer for the part 2. Part 1 is covered over here. Part 2 here. Done? Let's move on. Okay, the question number 15 now. 1 plus cos 4x in the root. We know that the root means you have to use identity to get rid of the root. 1 plus cos 4x will become what? Twice of cos square 2x in the root. This will become what? Twice of, so root 2 times of cos 2x dx integration minus pi to pi minus pi to pi. Okay, now cos 2x again modulus means what? Graph. Yes, superb. Cos x graph is this. That's my cos x graph. You know cos x means this will be 0, this will be actually pi by 2, but this is cos 2x, so it will become half of that. Whenever you have cos 2x means usually cos x has a interval of what? The period of 2 pi. Cos x, sin x has an interval of 2 pi, right? But cos 2x will have a half the period, 0 to pi by 4, and this will become what? 3 pi by 4, and this will be what? Pi. That's my pi. Okay, so check this out. Now I can break this whole thing into, what? First of all, I can write this as twice. No, I can use the property first. Minus a to a can become twice of, root 2 is outside, twice of 0 to pi cos 2x in the modulus dx. I'm using that property, minus a to a, what property I'm using, okay? Twice of 0 to a, twice of 0 to a is pi. Okay, now this becomes what? 2 root 2 0 to pi modulus, don't forget to write. It's modulus because check this out, cos is negative over here, sir. Cos is negative means if you integrate just cos, it will be wrong. You have to write minus cos over there. So then check this out. So basically I can break this interval from where to where? My interval will be from 1 second. My first interval will be 0 to pi by 4, which is positive. Next will be pi by 4 to 3 pi by 4. Here negative, this is plus, right? This is minus. I'll have minus sign over here, and 3 pi by 4 to pi will be again plus sign. Right? Okay, now I can open the integration. Have a look. This will become what? 2 root 2 is a constant outside. Now check the magic. 0 to pi by 4 cos 2x dx. Minus sign will come. For the first part we had a plus sign. For the next part, minus sign. This is what? Pi by 4 to 3 pi by 4. Minus sign because of this negative sign. It will become again cos 2x dx. Cos 2x dx one more time. We have one more. Just one more. 3 pi by 4 to pi. Same thing. Cos 2x dx. Done. Done. This is pakka done. This is 3 pi by 4 to pi. Okay. We know integration of cos 2x. Cos 2x integration is what? It is, sir, sin 2x by 2, sir. Sin 2x by 2. Sin 2x by 2. Okay, super. Super. Next, all is calculation, okay? So everywhere I'm going to get sin 2x by 2, sin 2x by 2, sin 2x by 2, okay? So I'll take that 2 outside. This 2 I'll take it outside. So far I have 2 root 2 and I have 1 by 2 as a constant. Please check. I'm taking 1 by 2 outside. It will become what? 1 by 2 sin 2x from where? 0 to pi by 4. Next what it is? Minus sin 2x pi by 4 to 3 pi by 4. Again we have a 1 by 2 over here also. And we have again one more time sin 2x 1 by 2 from where to where? 3 pi by 4 to pi. I'll take this 2 outside, okay? I'll take it like this. It'll become 2 over here and remove these 2's. I'll remove these 2's. Check. Check. Correct? Correct? I've taken the 2 everywhere outside. Now next is simplifications. Please be a little patient. Let's do it. I get little root 2 over here. Sin 2x at pi by 4. It will become sine of pi. Pi by 2, right? Pi by 4 into 2 will become pi by 2. So 1. Sin 0 is 0. So minus 0. Upper is 1. Lower is 0. Done. Next. There's a minus sign. Upper 3 pi by 2. So minus 1. No, plus 1. Right? No, minus 1. Correct. I'll have 3 pi by 4 into 2 will become 3 pi by 2, which is the third quadrant, right? So it is minus 1. And over here at pi by 4 will become what? It will become pi by 2. So plus 1. Please check. Here, very important. Sin 2x is there. 3 pi by 4 is the upper limit. Sin 2 into 3 pi by 4 will become 3 pi by 2. Third quadrant, negative. I've written here minus 1. Next is what? Lower limit. Upper limit minus lower limit. So I've written the minus sign here. Now check the lower limit. Sin 2 times of pi by 4 is sin pi by 2. Right? Pi by 4 is 45. Into 2 is 90. Sin 90 is 1. I've written here plus 1. Upper limit is minus 1. Lower limit is plus 1. 1 second. Upper limit is minus 1. Lower limit is plus 1. There's a difference because of the upper limit minus lower limit formula. Okay. Done. So far so good. Next, plus sign. The last one, sin 2 pi 0. Sin 2 pi 0. Next one, sine of, there's a minus sign over here. Sine of 2 times of 3 pi by 2. Again, minus 1. Again, minus 1. Please check. Sine 2 times of 3 pi by 4. 3 pi by 2. Minus 1 with the lower limit. Okay, so minus of minus 1. This is simplification. I get root 2 over here. I get 1. Minus 0 is cancelled. I get here minus 2 of minus 2. So becomes plus 2. This is again plus 1. Answer is 4 into this. So 4 root 2. Have a look. Have a look. 1. 0 is ignored. Minus 1 is minus 2. Outside minus means plus 2. Minus of minus 1 is plus 1. Answer is 4. 4 into root 2 is 4 root 2. Done. Question 15 is over. Next one. Question number 16 now. Okay. Previous answer is 4 root 2. Next one. 16th. Beautiful. This is odd function. Yes or no? Yes it is. Check this out. If you take ln of, replace, let's call this to be a function gx, okay? This will be a function gx. Let's try to find g of minus x. Will become ln of 1 minus x upon 1 minus of minus x. What is this? ln of 1 minus x upon 1 plus x. Let's do one thing. Take reciprocal. It will become 1 plus x upon 1 minus x to the power minus 1. Correct, na? I can take the reciprocal for the base, right? It will change. 1 minus x is here, 1 plus x is here. I'm taking reciprocal. So power becomes minus 1. Take the power in front of this. It will become minus ln 1 plus x upon 1 minus x minus g of x. Started with g of minus x. It means odd function. Odd function. G of minus x is minus g of x, so odd function. Odd function. Odd function from where to where? Minus a to a, 0. Minus a to a, 0. This part is 0. Integration. The other part, minus 1 by 2 to 1 by 2. Beautifully they have given us GIF to confuse us, no problem. GIF minus 1 by 2, right? This is the curve. This is the curve. Open, close. Okay. Close, open. Right? Over here we have minus 1 by 2 and over here we have 1 by 2. Break this. From minus 1 by 2 to 0, this will become what? Minus 1. Okay. And from 0 to 1 by 2, this will become what? 0. That's it. Please check. From minus 1 by 2 to 0, from here to here, what is the answer? Minus 1. GIF will be minus 1. From 0 to 1 by 2 will be always 0. So do not have to worry about. I'm gonna break this limits like this. Minus 1 by 2 to 0. This will be what? Minus 1 dx. And for the next part, 1 by 2 to, what is it? Sorry. Yeah, 0 to 1 by 2, no? My bad. This is 0, okay? Sorry. This is 0. 0 to 1 by 2 will be what? This is 0, right? Yeah. 0 dx. This part is cancelled, gone. What about this? There's a minus sign over here. I get over here x. From where to where? Minus 1 by 2 to 0. This whole thing will become what? Minus sign is outside. I get 0 minus of minus 1 by 2. Nothing but minus of 1 by 2. Option A is correct. Please check. Minus is outside, okay? It becomes upper limit is 0, lower limit is minus 1 by 2. So minus of minus 1 by 2 is plus 1 by 2. Outside is minus, it becomes option A, minus 1 by 2. Done. Please check. Understanding of odd even function, understanding of GIF is required to solve this problem. This is question like KCET problem. This question can be asked for KCET. Please check. Done. Superb. Question number 17. Same another problem on GIF. Greater integer function of x square. Root 2 is what? Root 2 is 1.414. 1.414. Okay. We know that we're looking for 0 to 1.414. So we can go from 0 to 1 and then 1 to 1.414. Okay. Over here, this will become what? This will become what? This will become 1, right? No, this will become 0. This will be 1, right? Yeah. Actually, square is outside over here, okay? Square is outside, not inside. Square part is outside, not inside, okay? Please check. So, if you look at the value of this, yeah, there's a mistake that I made. The square was inside, typing mistake. It is actually outside this GIF, okay? Please pay attention. 0 to 1 it is 0, 1 to 1.4 it is 1.414 it is actually 1. Graph I have already shown you. Here I have not drawn. Break this, I get 0 to 1. This will be 0 dx plus 1 to root 2 will be what? It will be 1 dx. 1 square actually, 1 square is nothing but 1 only. So no problem. We get 0 plus 1 to root 2 dx actually, right? What I get for this? I get the answer as x from 1 to root 2. My answer is what? Root 2 minus 1. My answer is root 2 minus 1, which is what? Option C, no? Please check. Option C is correct. That's my answer. That's my final answer. Root 2 minus 1 is my final answer. Okay, done. 17th is over, 16th is over. Question number 18. Now this is your homework. This is your homework, only homework that I've given you today. I hope you have solved the previous classes homework. You want the solution for that? Let me know. I'll give you the video solution. The value of 0 to 1, x 1 minus x. Homework, but I'll give you a hint. Take 1 minus x as t. Do this. Take 1 minus x as t. That's my hint. From here you can solve the question. Solve, please. This is the homework, guys. This completes your session and the chapter integrals. Homework is clear, right? Yeah. Had fun? I had fun teaching you this chapter of integration. It had a lot of concepts. I've covered all of them. If I missed something, you have to let me know in the comment section. This is it for today. Please solve the given homeworks. Take it very seriously. I'm telling you, I will not be able to teach you again in this much detail when we are going towards the examination time. Okay, we have to be very quick in our preparation. So that's why it's very important to practice the problems right now. Okay. So with this, I can end the session today. Had fun completing the, I think most of the calculus, 2 chapters are left. AY and differential equations, rest all is covered in calculus also. So with this, I can end the session today. I'll see you again very soon. Till then, take care. Bye-bye.